Good afternoon. Today we're going to be going over our 2.5 notes, which is domain and range of continuous graphs. We spoke in the last set of notes about continuous and discrete functions, where we had an emphasis on finding the domain and range of our discrete graphs. And today we're going to focus primarily, when I say primarily, I mean mostly, on the domain and range of continuous graphs. I will preface this by saying that for a lot of students, they have a really difficult time with this concept. So I'm going to do my best to teach it as clearly and slowly and with as much information as I can. This set of notes may be longer than a lot of other notes that we have done, and I apologize for that, but I really want to make sure that you have a good foundational understanding of domain and range of graphs that are not discrete graphs, because you will see a lot of questions like these, and you will have to focus on this quite a bit when you take like your STAR test, and moving on up into the other math classes that you take. So don't feel upset or whatever if you're having a hard time understanding this. It is something that is difficult for a lot of people when they first learn it. Just remember that the more you can practice, the better you will be at this stuff. Okay, so now that I've just done my spiel, we're going to move on. The learning target for today is I can determine reasonable domain and range values from discrete and continuous linear situations and justify my thinking. But like I said, today we are focusing primarily on continuous graphs. We have two or three actually vocab words. The very first one is compound inequality, and that is an inequality that is comprised of two inequalities together. So we talked at the start of this unit, or I guess maybe in unit 1, I don't remember. We talked very minimally about compound inequalities and what they look like visually on a graph, and then what they look like when you write a compound inequality down. What we're doing today is going to consist of a whole lot of compound inequalities, okay? So remember that you are taking two sets of data and you are putting them together into one set of data, if that makes sense. Continuous functions, specifically graphs, these are graphs that are unbroken and can contain all types of values such as whole numbers as well as, or integers as well as decimals, okay? So we can have integers, as well as decimals, okay? So that is what makes continuous functions a little bit more challenging than discrete functions, is you have all of these possible values that can be contained in your domain and range. And so it's a lot more difficult to list all of them because you can't physically list all of them. All right, and then one thing that we're going to see today is something called all real numbers. We use this phrase when our domain or range values are all possible real numbers. The symbol we use for all real numbers is, I'll show you in a second. So this is all possible real numbers. The symbol we use is this, okay? It is one line and then another line, and then you make the letter R. My students, after a while, get really lazy and do like a T and then an R. That's not what this is. It's not a T and an R. It is an R with an extra bar on it, if you will, okay? So it is an R only, and it's got like a thick, almost got like a thick little leg there, okay? So we will use that for all real numbers, and you'll see that symbol a lot today. Okay, so we will list the domain and range values of these two graphs, but I want to remind you that these are discrete graphs. You can look at the graph and you can say to yourself, I know exactly where each one of the X values that are contained in my graph fall and where each one of the Y values in my graph fall. You can see them, they're right there, okay? They happen at these coordinates. So what we do as a reminder is we come off to the side over here and we list all of our coordinates so that we can list our domain and range. So I'm going to start down here with this first dot. We've got a 2 and then a 1, and then we've got 3, 4, and then I've got 5, 6, and then I got 7, 5, and then I got 9, 3. Okay, everything in this first column here are going to be my domain values or my X values, and everything over here are going to be all of my Y values. So what we're doing is we're looking at our graph and saying, where's all my data located at? Where are all my data points located at? Well, they're located right there. You see them? There's 5 coordinates, so our domain and range are going to have those coordinates there. So we've got a 2, a 3, a 5, a 7, and a 9. Close. Now what we're going to do is we're going to write our range values down. We got a 1, I see a 3, I see a 4, I see a 5, and I see a 6. You don't have to write them in order, but that's what I'm going to do. Okay, you can do the same thing for the second graph. I'm not going to do that one. It'll be done for the notes key. But when you look at this graph, you know where every single point is located. They're right there. Okay, this is a broken graph. There is nothing connecting those points to each other. They're just dots thrown on a graph. You can see them. You know the domain. You know the range. Okay, now if I give you a graph that looks like this, okay, there is no longer a single coordinate. If you look at this graph, you're saying, well, yeah, there is. There's one right there. But notice that there is shading on this graph. And remember that when we talked about inequalities a long time ago, the shading represents all of the values that are contained within that inequality. Okay, so that's going to make a difference for us when we look at this next graph example. Okay, I'm going to come back up here for a second though. Continuous graphs are comprised of unbroken data, unlike discrete graphs. The lines that connect the points on continuous graphs are a visual reminder that between two whole number points, there are an infinite number of other values present, such as decimals. Because of this, it is important to list every single value within a continuous function. We will use inequalities instead to show all the possible domain and range values. So we are going to be using inequalities today. Okay. We will no longer be using sets, those little squiggle brackets that you see. We can't do that because it is impossible to list every single value that is contained in this graph. So we know for a fact that our data points start here. But then if I said, put another point on your graph, you could say, well, there's definitely data here. But what about here? Isn't there data right in between? And then isn't there data in between that and in between that? And then isn't there data in between that and in between that and then in between that and in between that? Like, how in the world am I going to list that? And then what happens when I move over here? There's a data point there, but there's data here and then in between and then in between and then in between, in between, in between, in between. And then, but there's an arrow, which means that this solid line just keeps on going that direction. Okay, how in the world am I supposed to list every single one of those values? There's an infinite number of values within these graphs. So what we're going to do is we are going to look at our domain and range as a room, if you will. Okay, so think about a room. A room has two walls and a ceiling and a floor. Okay, and we're going to use that to kind of help us map out where our possible domain and range values will go. When I teach this to my kids, I try to use words that will help them remember. Domain are going to be the doors of your room. Okay, when you look at a door is a vertical line. So our domain values are going to go this direction. Okay, they're not going up and down. Well, they are going vertical. They're vertical values, okay? Your range, I don't want to say floor and ceiling because it's not an R, so what I tell my kids is the rug. The rug goes on the floor, okay? So your ceiling and your floor are going to be horizontal values, okay? So what I do is I ask my kids, I'm going to grab my little laser pointer here, and I'm going to say, okay, looking at my graph, I can see where my graph is. Do I have any doors over here on this side of my graph? And you should be looking at this graph and saying, no. Well, as I move from one side of my room to the other, bam, okay, I all of a sudden have a domain value. So what I'm going to do is I'm going to draw myself, it's ugly, I'm going to draw myself a vertical line, okay? That right there is the number 1 on my x-axis, okay? All right, now I gotta go back. Oh, my laser pointer. I'm gonna go back to my laser pointer and I'm gonna say, do I have another domain value right next to it? And the answer is, yes, I do. Do I have another one? Yeah. Another one? Yeah. Do I have x values all along here? And the answer is yes. Now, remember that that's an arrow pointing to the right, which means that my graph is, my graph is continuing to go this way, even past what I can see. So do I have domain values here? Yeah. Do you see my green line just keeps hitting this line? Well, where do they stop? The answer is they don't. They continue moving in the right direction, the right-hand direction, for infinity, for forever. Okay, so when I ask you what are all of the x values that are contained within your graph, you definitely don't have all of them because there aren't any over here. We've already said that there's no domain values over here. They start here at 1. So what I want you to do is I want you to write down the letter x because those are your domain values, and then the number 1. And then the question is, are your x values in your graph bigger than 1 or are they less than 1? Well, if my domain values are this way, are those numbers on my number line or in my graph bigger than 1 or less than 1? Well, all those numbers are bigger, right? Here's the number 2, here's the number 3, here's the number 4, here's the number 5, here's the number 10. So your x values will be greater than or equal to 1. And that represents all x values that are in your graph. Okay? Now what we have to do is we have to look at our range values. And our range values are like the rugs in our room. They go this way. Okay, I'm going to erase this just for now so that we can see what's going on. Okay, so do I have any y values down here? No, my graph doesn't exist down there. And you're like, oh, la, 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 la. I have a range value here. But as soon as I move up from that value, do I have any ranges? And you should say, no, my graph only stays on the x-axis. Well, if your graph only stays on the x-axis, that means that your y values are only ever going to be located here, okay? That is one value. If I were to make coordinates for every single point on that graph, they're all going to be a number, comma, and then the same y value. And that y value, if you look at your graph right here, that y value is 0. So your y values equal 0. And you're probably looking at this and saying, I do not know at all what you just said. I apologize. I know it's weird. I know it's funky. It'll get easier the more practice that we do. Please don't shut down yet. I promise. Look at this. Look at the amount of notes we have to do. There are so many of them, okay? You will feel better in a little bit. I promise you. Promise. Okay. Moving back over here. We are looking at our domain doors. And our ranges are our rugs. Okay, remember that range values are horizontal and domain values are vertical. So I always start with domain because I think it's easier to see visually than range. All right, when you start at your graph, do you have any domain values over here? And you should say, yeah, I do. There is a arrow on my graph, which means that my domain values are going past everything that I can see, even way over here. Okay, they exist, they exist, they exist, they exist, they exist. They're there, they are all there, and then bam, they stop. And then after that coordinate, do you see that I don't have any more x values in my graph? They don't exist. They're gone. Well, that means that I have an endpoint here. Okay, what is that x value endpoint? It is a 1, 2, 3. Okay, and then my graph doesn't end anywhere else. It just keeps going. All right, so you're going to write down your x and you're going to write down your 3. And then the question is, are the x values that are contained in your graph bigger than 3 or less than 3? Well, they're all over here. All of my x values are over here on this side. Are these values on a graph bigger than 3 or less than 3? Well, they're less than 3. So your x values are less than or equal to 3. And you say, okay, Miss Olmsted, whatever. All right, and then we now need to look at our range, which are our y values. Do I have any that exist down here? No. What about here? Nope, 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 nope. Yes. No, 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 no. So just like with the other problem, my range values only exist in this one place. And that is where y is 0. So y will equal 0. Okay. All right, let's move on. Now we're going to run into a graph that does not have arrows. I actually think not having arrows makes it easier. This is still a continuous function, okay? Between those 2 points, my graph is unbroken. I don't have to have arrows for it to be continuous. But now I got to say to myself, okay, let's look at our domain values first. I'm going to stop writing this eventually, but these are our doors. Our doors are vertical. These are our rugs. Our rugs are horizontal. Got the hiccups. Okay, so when I look at my graph, do I have any x values that exist over here? The answer is no. But then, boom, I have an x value. My x's start there, and that is 1, 2, 3, 4. That is at positive 4. All right, and then I'm going to keep moving, and I move, and I've got x values, and I've got x values, and I've got x values, and then I all of a sudden don't have x values. So you should say to yourself, ooh, I have a starting point and an ending point. That's going to make my life easy. Well, what is that coordinate, or what's that value, that x value? That x value is 2. So when you look at your graph, you should say, ooh, I have x values contained between -4 and +2. And you should say, okay, so the x's only exist in between those numbers. So the question is, can I list them all? Well, no. Because although I have one at -4 and -3 and -2 and -1 and 0 and 1 and 2, what about all the halvesies? And then all the fourths? And then all the 1/18ths? And then there's an infinite number of coordinates in between those coordinates. There's no way for me to label them all or list them all. So instead, I'm going to use inequalities to represent all possible values contained within my graph. Because I have a starting and an ending point, I'm literally taking those values and having a starting point and an ending point. My x's are in between them, okay? So when you have a start and an end on a graph like this, everything has to be bigger than -4, but also smaller than 2. So my inequalities are going to be less than or equal to 2, but that's going to be greater than or equal to -4. And you're looking at that and you're like, but that doesn't say greater than or equal to, but it does. It's saying that your x is greater than or equal to -4 because the inequality always eats the bigger thing. If you put your starting and ending point in this inequality, in this compound inequality, going from the smallest on the left to the largest on the right, then the inequality symbols will always open up towards the bigger number. It does not make sense for you to do this. X cannot be bigger than 2, but also bigger than -4 because my values don't come out over here, which would be my x is being bigger than 2, okay? Your inequalities should never face opposite directions. They should always face the same direction. And for us, it's always going to eat the bigger thing, and 2 is the bigger thing, okay? So when you look at that compound inequality, you should say to yourself, my x values are between -4 and +2, and it can be anything in between -4 and +2. It could be -3.99999999999999999999999999999999999999999999999. Okay? That is between -4 and +2. Okay. Now, when I look at my range values, I'm going to erase this again. When I look at my range values go this way. But again, as I am moving, bam, they are here and then they're nowhere else. So just like with those other problems, my y value is still only at 0. Okay. Now our graph looks like this. I'm going to grab my whatever this thing is called, laser pointer, okay? And I'm going to check for domain values. And remember that domain values go this way. So I'm starting over here. My graph contains no x values. And then, bam, I have an x value, and then, oh, they're gone, okay? The only spot that my graph contains x values is right here. And that x value is 0. So this graph has an x value of 0, and my coordinates can be nothing else. They are 0, and that's it. There's nothing else they can be, okay? Now, what happens when I grab my highlighter or my laser pointer and I start looking for my range values, my y values, my rug values? My graph doesn't contain any down here. And then all of a sudden, I start moving, and then bam, there's my first y value. So I'm going to come back over here, and I'm going to label that. What is that y value? That y value is -2. And then as I make my way up my graph, hopefully you see that there's an arrow up here, which means that my graph is going to continue on and up forever. So you know that your y values have a starting point but no ending point. Are the y values in your graph bigger than the starting point? Are these values up here bigger than -2, or are they smaller than -2? Well, hopefully you're saying that they're bigger than -2. So you're going to say y is greater than or equal to -2. Domain values go this way. I don't have any. I finally have one, and then I don't have any again. So just like with the other problem, my domain value will be 0, and that's it. Okay, now let's look at our range values. If I start down here at the bottom, I always start at the left and the bottom. If I start down here at the bottom, there's an arrow here, which means that I do actually have y values down there. Remember that this just goes down forever. So when I start at the bottom of my graph, I technically have y values. They're all located right there. Got them, I got them, I got them, I got them. They're still there, they're still there. And then all of a sudden they stop. And they stop here at this point. So I need to make that point my starting/ending point. And that is going to be 1, 2, 3, +3. So I know, because I only have one either start or end, I've got y is something compared to 3. So when you look at all the y values in your graph, are all of these y values bigger than 3, or are they smaller than 3? Well, on a graph, this is 2, this is 1, this is 0, this is -1, -2, -3, -4, blah, blah, blah. All of those values are smaller than 3. So your y value will be less than or equal to 3, because they're all going this way. All right, domain. I only got one right there. And then I'm traveling along. So just like everything else I've done so far, your x is equal to 0. Your range. Range is going to get a little tricky. There's no arrow on here, so that means that I'm going to have a starting point. They start here, and then I'm going to keep on moving. They end there. So this has an actual floor and ceiling. None of the other problems have had a floor and a ceiling. This one does. This is 2. This is -4. So your range values will be -4, 2. Y is going to go in between now because these are range values. And remember that your inequalities always have to open up towards the biggest number. So everything has to open up towards 2. And that is saying that all of the range values in my graph are between -4 and 2. It can be anything between -4 and 2. It could be 3. I'm sorry, it could be -3. It could be 0. It could be 1.2579836542982. It can be any of those, okay? Okay, I'm going to skip number 7 because it's the same thing. My y values have just been shifted up. And I'm going to look at number 8 because we haven't seen one yet that is not centered on an axis yet, okay? So I'm going to grab my laser pointer, and I'm going to do my domain values first, which are our doors. They go up and down. So when you look at this graph, notice that there are no arrows on the ends. There's actual endpoints. So I know that as I move, I'm going to actually have a starting point for my x's, which are here, and that's -1, 2, 3. And then as I move, I still have x values in my graph, and then all of a sudden, they stop right there. So that is going to be where my x values stop, and that is at +3. So because my x's have a starting and ending, my inequality will have a starting and ending, and it will open up towards the bigger number, which happens to be 3. Now I'm going to look at my range values. There are no y values down here. The first time I hit a y value is there. So I'm going to draw it all the way across. That is -1. As I keep checking for y values, all of a sudden, bam, they end there, and then there's no other y values above this one. So I'm going to put my y value stopper there, 1, 2, 3. That's a +3. Your range will be -1 is less than or equal to y, which is less than or equal to 3. And hopefully you're starting to see a little bit more like, oh, I can tell what's going on. I can kind of see it. Okay, we're going to look at number 9 next. Number 9. I don't have any endpoints here. My graph has arrows on both ends. That means that my graph is going up this way and down this way, okay? So let's talk about our domain first. Our domain are our vertical values. As I move across my graph, I don't have any values until I hit this number. And then as soon as I get off of it, I still don't have any more values. So what is this value? When you look at your x's, it's 1, 2, 3. It's -3. So x can be -3 and nothing else. So x will equal -3. Okay. Now the range. This is where things get really tricky. I have y values down here. Remember that this arrow is going down, which means that I have a value all the way down here. All the way here. Still have y values. I still have y values. And as I go up into infinity, I will still have y values. So because my graph does not have a starting y value or an ending y value, I actually don't know where my graph starts or ends because it doesn't have a start or an end. This graph is the first graph that I have that will contain an answer of all real numbers. Any y value that my brain can comprehend will be contained in this graph somewhere. So this will be the first time that we use our funky looking R to describe all of the y values possessed in my graph. There's an infinite number of them. They're all available as long as they're a real number and not an imaginary number, which there are such things as those, but you won't see that till Algebra 2. All real numbers, every number I could imagine, -1 billion is contained in this graph. 5 is contained in this graph. Negative 1,197 is contained in this graph. Any y value in existence is contained in this graph because I have those 2 arrows on it. Okay. All right, I'm skipping number 10. Let's look at number 11. Number 11, I've got arrows on this thing, so I know that my graph extends past what I can see in both directions. I'm going to start with my domain value first. Do I have any x values over here? Yeah, my graph keeps going. I just can't see it. And as I move across, notice that my graph I still have x values. Still have them. Still have them. Still have them. I'll still have them over here. I have them over here too. Okay? So this graph, my domain is actually all real numbers. My range, on the other hand, I don't have any y values that exist in my graph down here or up here. They only exist here. That y value is -2. If you were to draw a line across so you can see it, that is at -2. So my range here is y is equal to -2. Looking at number 12, I've got arrows, which means that my graph is extending this direction. So we're going to grab our laser pointer and we're going to ask, do I have any domain values here on this graph? Yes. Still got them. Still got them. Still got domain values. Even over here. Even over here, I'll still have them. They're just going up this direction, right? They're just still going up past what I can see. They go all the way off the graph, okay? So because my domain values are everywhere, all of them that I can think of exist, it's going to be all real numbers. And then the range is going to be the same way. Remember that this extends down and this extends up. If I check, will I have a range value all the way down here on my graph? I will. It'll be over here somewhere, okay? As I move, I still have range values. Yes, I do, and I keep going, and I still have them way up here, which means that my range value is also all real numbers. I will give you a clue to help you. If your graph has 2 arrows on it pointing in opposite directions from each other, something will be all real numbers on your domain or range. It'll either be the domain or it'll be the range, and on occasion it will be both. So like if you look at number 9, that's the first time we had 2 arrows. My range was all real numbers. None of these other ones had 2 arrows, and none of my answers were all real numbers. Okay. As soon as I looked at 11, my domain was all real numbers. That had 2 arrows going in opposite directions. And then number 12, I have 2 arrows going in opposite directions, and they both ended up being all real numbers. Okay. All right. Now, if you look at 13, 14, 15, and 16, all of these look like questions that we've already done, but there's a slight difference to them. And the slight difference is if you look at where the coordinates are, like where the endpoints are on those graphs, they are no longer what you call a closed circle. They are now open circles. Everything that we've done on all of these other graphs have been closed circles. So if you think back to middle school where you learn, I guess even elementary school, where you learned about inequalities, you have 2 options with inequalities. You have an open circle or a closed circle. A closed circle are going to be all of your greater than or equal to and less than or equal to. All of your open circles are going to be your greater than and your less than. So open circles mean that your inequality symbol will not contain the equal sign. If you look on every single one of these questions where I had an inequality symbol, notice that every single one of them had an equal sign on it. Okay, all of them. All of them have it. Even this one that I didn't do, which I can do for you really fast, the domain is 1, 2, 3. This is x is less than or equal to 3. And then your range is y equals 3 on this one. Okay, my inequality symbol right there has an equal sign on it. So all of these have an equal sign. This one's going to have an equal sign. My domain is x equals -3. My range is y is greater than or equal to -3. So all those inequality symbols have an equal sign on them because all of those are closed circles. Now, once I hit a question like number 13, the process doesn't change for me. I am still looking for domain values, which I have all over here. They eventually stop here, okay? And what I'm going to do now when I draw my little border line that I've been drawing, because I have an open circle, I'm going to draw a dotted line. And that's going to help me remember that I'm not going to have an equal sign on my inequality symbol. This is still at 3. Okay, and then I don't have another ending point. There's nothing over here, and this is an arrow that goes on forever this way. So that means that your x values will be less than 3. But notice that that inequality symbol does not have an equal sign on it. It just says x is less than 3. No more equal sign. My range only exists in one location. It exists here. That's at positive 3. Because it only exists there, I'm going to go ahead and just put y is equal to 3. If it's an equal to, it's just a good old-fashioned equal to. The only time you have to check those symbols is if you have an inequality. Let's take a look here. My domain values start at this number, which is 1, 2, 3, 4. This is negative 4. And they end at this number. But notice that both of those endpoints are open circles. That means that my inequality symbols, when I draw them, must not contain an equal sign. This will be negative 4, 2, x goes in between. Those inequality symbols are still going to open up towards the bigger number, but they're not going to have an equal sign on it. My range is only located there. That is y is equal to 0. Hopefully that makes sense. Now, if I take a look at something like number 16, what happens if you have one coordinate that does have an equal sign and one coordinate that does not have an equal sign, or one that's an open circle, one that's a closed circle? The good news is nothing really changes, okay? My graph starts there and it ends there. That means that one of my inequalities will have an equal sign and the other one won't. This is negative 3. This is positive 3. At negative 3, I will have an equal sign. At positive 3, I will not have an equal sign. Same thing is true for my range. My range values start there at negative 1, and then they end all the way up here at 1, 2, 3, at positive 3. So at negative 1, I will have an equal sign. That's not a negative 3, that's a positive 3. At positive 3, I will not have an equal sign. Does that make sense? Hopefully it does. I can't tell if it does or not because I'm not seeing your face. Okay, now, things are going to get funky when we start moving down to other types of graphs, okay? Here we have a bunch of linear graphs. These are all linear. We've done a bunch of linear stuff. Now we're going to look at a graph that isn't linear. What's that? Why is that there? It's okay if it's not linear, okay? We're still going to do the same thing that we've been doing. So as a reminder, domain are our doors. It is our up and down, our vertical values. Our range are our rugs, which are our horizontal values. So I'm going to do the same thing here that I've been doing for my linear graphs, okay? Do I have any x values contained over here? No. The first time I have an x value is there. So I'm going to go ahead and drop my x value down. Now, it is an open circle, so I am going to make sure that that's a dotted line. And then as I move this way, my graph contains x values. And then all of a sudden, bam, my x values stop there, okay? It's a dotted line because it's an open circle. So this is going to be from negative 1 to positive 3. So I've got negative 1 is less than x, which is less than 3. Because both endpoints contain an open circle, both of the inequalities are going to have are not going to have an equal sign on them. Let's check our range value, shall we? Coming down here, I don't have any range values, and then bam, all of a sudden my y values, my graph starts here. So I'm going to go ahead and draw a dotted line. Both of those dots are open, or both of those circles are open. That's at negative 2. And then as you move up the graph, notice that my y values stop there, and then there's nothing above it. So right at the top of this little upside down U-shaped graph, my y values stop. There is not an open circle there. So what we do is we say that we assume that it is a closed circle, and we're going to have a closed circle, which means that my line will be solid. So I do still have a starting and an ending point on this graph. It's just a different shape than the linear ones that I was looking at. So this is going to be negative 2 is less than y, which is less than or equal to 2. Okay. Let's look at number 18. I don't know what this is up there. Just ignore that. Okay. I'll fix it, I think, before I give this to you. Okay. Let's look at the domain. So the domain are our x values. They go this way. They go wee, and they start there. I'm going to draw me a dotted line, and that is at negative 1, 2, 3, 4, 5, 6. Negative 6. And then as I continue moving around my graph, bloop, 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 they stop there. There's no x values in my graph past this coordinate. That is a closed circle, so we're going to give it a solid line, and that is at 0. So my domain values are between negative 6 and 0. At negative 6, it is an open circle, but at 0, it is a closed circle. Checking out my range values, they go this way. The first range value that I have is right here. That's where my graph starts. Because it doesn't have an open circle, we assume it's a closed circle. So we're going to draw a solid line. That's 1, 2, 3, 4. That's -4. And then as I make my way up my graph, I have y values until here. Here's where they end, okay? Now, here's where things get a little bit funky. What do you do if you have 2 points at the same spot on your graph, but one is open and one is closed? Well, if one is open and one is closed, then it's closed. And you can draw a solid line. And that's 5. So your graph is going to go from -4, which is less than or equal to y, which is less than or equal to 5. Okay, let's take a look at 19 and 20. They're both very similar. So when I look at 19 and 20, I have these arrows on my graph. Now, the way that these arrows move, strange. The way that these arrows move is my graph is actually going up and out forever this way and this way. It doesn't look like it, but the 2 lines that are going straight up are not actually going directly vertically up. They are opening upwards and outwards the entire way up the graph. There's arrows on both sides. If there's arrows on both sides and they're going in opposite directions, remember that something will be all real numbers. Let's figure out what it is. I'm going to check my domain first. So my domains are my x values. Will I have an x value over here? Yeah, it'll be way up here, but I'll have it. As I move across my graph, I still have x values. They're there. They're there. We're still chugging along. I still have them. I will have them over here as well as off my paper, okay? So because of that, the domain is all real numbers for this graph. The range, however, I don't have my graph down here. My graph doesn't exist. The first place it exists is right here. So I'm going to go ahead and draw me a green line. And that is at -2. And then as I make my way up the graph, notice that my arrows are going up forever, so I know that my range values are going to continue to go on forever. So I only have one input, or one end point, and that is at -2. So we're going to do y in -2. And then are my y values in my graph bigger than -2 or smaller? Well, they're all up here, and all these values on my graph are bigger than -2. So your y values are greater than or equal to -2. And that is where I'm going to stop our notes. I am going to finish the last couple that I skipped, so it would behoove you or benefit you to try them on your own and then check to see if you got the right answer based on the answer key that I have provided for you. Okay, please, 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 if you are struggling with domain and range of graphs, which it is totally understandable if you are, go see your teacher during their normally scheduled tutorial times. This is a topic that a lot of Algebra 1 students struggle with when they first learn it. I don't know why. I mean, I get it. It's very weird, okay? But please don't just say, I don't get it, and shut down and not try to get help with it. We want to help you. It takes practice. It takes time to get it. So please go see your teacher. Rewatch this video 500 times if you need to. That's the great thing about videos. But please do what you can to ensure that you are learning the material and that you are going out of your way to be prepared. Okay? All right, that's all I have for you. I'll finish this and post it for you. But